You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Get low, get low, get low. This week, we're discussing the pitfalls of going low level in a high level language. We'll discuss the kinds of problems you have to navigate around when you start trying to use a high level language like C# to do things at a low level. But before we get started, Will, what have you been fighting this week?
Well, last week I wrote documentation, and this week I have transitioned into doing a lot of low-level code in Delphi to deal with security-related stuff. Let's just say there was a little bit of a shock, getting back to it. I'm also in the process of tearing down the web hosting offering that I have, for a number of people, and trying to get like all these domains to their rightful owners and, move everybody off of WordPress that I possibly can, so I quit maintaining it. So yeah, that's what I've been doing. I'm also fighting a migraine right now as we're recording. So it's a bit of fun. How about you?
Well, I have been working on talking to other internal APIs. We're working kind of towards an enterprise services design to keep from reproducing code. And hopefully in a few months, we'll actually be taking those connections to the services and putting them in packages like NuGet packages and NPM packages. I might even get to write some templates. So that's something you and I need to sit down and talk about. But kind of been looking into that anyways on my own, just sort of in preparation. Also, I shouldn't be allowed to write intros when on pain meds or after playing old school Need for Speed.
Yeah. I was wondering about the genesis of that one. That's way better than what I thought.
Yeah. I hurt my foot early this week, and I'm on not really high-level pain meds, but yes.
Low-level pain meds?
Low-level pain meds. But I was a little bit out of it last night, so it was first night on the medicine, and I saw your outline and wrote that intro for it. But speaking of getting low, I have something for your fire alarms for IoTs. So let's go ahead and roll the music. This week for IoTs, I have something that you can add to your existing fire alarm. It's called Roost. And Roost doesn't replace your smoke, carbon monoxide, or whatever alarms, just the 9-volt batteries inside it with a connected lithium-ion battery that will last up to 5 years. It's the size of your normal 9-volt with electronics to notify you of the alarm going off if you're not at home, or send messages to friends or family. It'll also notify you via phone of low battery status. The lithium-ion battery is replaceable, so you don't have to buy a whole new Roost when it goes out. These are available at places like Best Buy or Amazon for around $35, and I'll include a couple of links to them in the show notes. Who's talking to us this week?
So yeah, we had a comment on the website. It says, with having so much content and articles, do you ever run into any issues of plagiarism or copyright violation? My website has a lot of exclusive content I've either created myself or outsourced, but it looks like a lot of it is popping up all over the internet without my authorization. Do you know any techniques to help protect against content from being ripped off? I'd certainly appreciate it. As far as issues of plagiarism, I don't think anybody's really stolen anything from us. It would be kind of amazing if they did.
Yeah, that was
it's like, hey, buddy, it's your foot.
We try to treat our episodes almost like research papers in college, where we'll put references and stuff like that in there.
Yeah, plus it helps with people finding more useful stuff. I think the other big thing is that our content is not the thing we're selling.
That's true.
It's a lead magnet for things that we're selling eventually.
Yeah.
That don't exist completely yet, that we're kind of working on that.
Mm-hmm.
And as a result of that, it's somewhat okay with us if people get a hold of things potentially. Like, that's not something we consider to be a significant risk.
Yeah.
In this particular context. And the big thing is too, that with me being in development as long as I have, and you starting out, our big thing is more about improving the landscape of software development. And it's like, oh, good, you stole some of my ideas and you shared them with other people. And if any of those people took those ideas seriously and improved things, I still win.
That's very true. Our big goal is to disseminate information. So somebody stealing our ideas isn't exactly plagiarism so much as passing on the knowledge.
Yeah.
So for us in this instance, that really does not apply. But I do want to thank you for your comments and send us an email to neckbeards@completedeveloperpodcast.com with some contact information, and we will send you a Complete Developer water bottle. And guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Path and Tumblr. I want to point out that since we've gotten our comments up and working again, we are going to give precedence to comments on the website when picking what to read because we want to get some discussion going on the site.
Well, that way, and it's also easier for us to find the contents there, and we're kind of lazy.
Yeah, that's very true.
Let's be honest here.
Yeah.
If you regularly do software development in a higher level language, you'll eventually run into a situation where you have to deal with the sort of problems that higher level languages aren't really built for. In fact, they're built to avoid. And these problems may cause application crashes, data corruption, performance problems, and the like until you get them sorted out because you're trying to do something that the language isn't really built for, and nobody that uses the language in particular uses it for this. And worst of all, your experience in the higher level language can often work against you in a lower level. We're going to discuss a few of the things that you need to be aware of on the inevitable day when you have to write or work with lower level concepts in a higher level language. And we're going to explain this with a bias towards Windows and particularly .NET, talking to lower level stuff. And these things apply in other platforms, but this is stuff I've done a lot of. Even back before .NET, I was doing this in Visual Basic. It was a lot of the same kind of problems.
This is also a case of Will going full med student. I looked through this outline. I'm like, dude, you wrote one like me.
Yeah, there's a lot. So let's get started.
All right, to start off, memory management.
Yeah, so if you're using a higher level language, particularly ones that have garbage collection algorithms like JavaScript, JavaScript has garbage collection. Mm-hmm. Java does, .NET does, some of the others do as well. Yeah. Those algorithms may not work all that well for you managing memory at a lower level. In other words, if it's garbage collecting, it may do it at a time that is extremely inconvenient. And if you're doing real-time stuff or trying to get close to real-time, it may burn you. The other thing is a lot of those things are not, you may allocate memory that is not controlled by the garbage collector because it has to be, pinned in memory, let's say, or something like that. Or it's like a window handle or a graphics device context or some of those kind of low-level constructs that are meant to be used by C programmers, but they're now available to C# programmers. Those are not managed by the garbage collector, and as a result, you have to remember to deallocate them when you've allocated them, and you're not in that habit.
Yeah, that's true because you're used to letting the system do it for you. You also learn that you want to be careful about how you allocate memory, grabbing more than you need as a buffer.
Right. So, like if you're reading off of, let's say, like a file reader in .NET, mm-hmm. You can do it a byte at a time. That file reader is pulling a buffer. It's going to pull like 4K at a time, because that's what the hard drive can do. You pull a chunk all at once versus a byte at a time because you're going to wear that hard drive out. When you're going lower level, they give you more granularity about what you can actually do, and you're actually doing that versus it's an abstraction that has a buffer protecting you. So you have to be careful about that. So that will get in your way a lot.
Another thing that a higher level language will do is copy memory around for you.
If you're working with graphics in .NET, for instance, this is one I ran into a while back, I was trying to take a byte array and turn it into an image. And, I have the byte array, I have a pointer to a byte array, and I'm saying, okay, I want to take this and turn it into an image, and I use their code. Well, what they're doing under the hood is they're actually making a copy of this image. Well, when I dispose that image, the byte array is still sitting there, and it's not getting deallocated. And so I was having a pretty fast memory leak because it was big images. As a result of that, you have to be aware of that being a potential problem. And another thing you've got to know is the difference between the stack and the heap.
Well, this took me a while to figure, to really get my head around.
Yeah. The stack is basically what stuff gets created on when your program is in operation and you're calling a function. It's like, okay, I'm entering this function. These things are on the stack. I do the stuff. And when I come out of this function, those things are gone, typically. But the thing is, they can also be pointers to things that aren't gone. So you got to be careful about that. And those things that aren't gone would be on the heap. And if you allocate stuff on the heap, it stays there. They call it a heap because you throw crap on it. And memory management gets very, very tricky with that because not only do you have the heap, but typically, in the higher level languages, you have a managed heap that's managed by, the garbage collector. And the way that those things are optimized, you have multiple levels, or at least in, .NET. And I think Java has this as well, where like Gen 0 on the heap is, for objects that you allocated real quick, you did something with, and you let them go. When you get memory pressure, those get blown away. Gen 1 doesn't until you get more memory pressure and it hits it and it goes on down. So if you have something that is a big chunk of memory and it sits there for a while and it gets all the way down to like Gen 3 on the heap, when the garbage collector runs, it's never going to deallocate that. And that thing may have stuff in it that you really need deallocated, like, a big chunk of your RAM. It may have, things like window handles, graphic device context, stuff that you have a low system limit of, like 2048 of them. And if you run out of them, you're done. Like, your GUI stops working. And that can get pretty important.
Okay.
Now, the other thing is your higher level languages have a tendency to put stuff on the heap. C# has got a very heavy bias towards the heap because of what it's intended to do. It's like, I want to keep these things around. And if I want to pass a reference, I want to pass a reference to it, but it's allocated somewhere else. It's out, it's on the heap. If you go lower level, you tend to have a lot more stack-based stuff. Or, like in Delphi, I can say, okay, this thing is passed and it's put in a register CPU. The thing with stuff that really, really clutters up the heap is, and we're going to talk about this here in a minute, is that this can expand the memory space of your application, and doing that increases cache misses on the CPU, which makes your app slower by several orders of magnitude.
So what's a cache miss?
That is where, you get multiple levels of cache at CPU level. And essentially, if it basically tries to predict what you're going to need and keeps it in higher speed access locations.
Okay.
If you have a cache miss, it's not there and it has to pull it out of memory or pull it out of a lower speed.
Okay,
level.
so...
And if you're allocating a ton of stuff on a heap, the odds of any one thing being the thing that actually happens to be there is pretty low because it's a very small cache.
Okay, I see
give or take.
Yeah.
I mean, it's a little more complicated than that, and we really need to get somebody that really deals with that low level to get into that. I've been burned by it. Not 100% certain that I understand it well enough not to have somebody, absolutely hate me for the way I'm going to explain it.
Yeah, I follow you.
Now, it gets even better if you're going to something that, if you're trying to interact with a platform that is not necessarily super low level, like dealing with, if you're dealing with the L2 cache on your processor from .NET, you should punch yourself in the face. Like that, why? With some notable exceptions, you probably don't need to be doing that. But what you might end up doing is dealing with something that's a mid-level language, like, you have C++ that's, mix, that's a mix of managed stuff and COM.
Okay.
Because COM has got its own memory management deal. So you're not necessarily just, interacting with the operating system and how it manages, to allocate, deallocate memory, but you may have another layer on top that you also have to talk to. And you may be talking to both of those at the same time as you're talking to yours, depending on what you're doing.
Yeah, I follow you.
And, things like COM, COM does reference counting. So it's like, okay, I know that this thing is referenced by this, and this other thing that's using it has to say, hey, increment the counter so you don't delete yourself until I say you can. Well, if this other thing doesn't say, hey, I'm done with you, it just hangs out there. So you'll have to deal with those lower level constructs as well, potentially. .NET is decent-ish at dealing with some COM stuff, but it's not baked in very well because it can't be. And so that can be very painful. So memory management is probably your number one issue. This is why it's the first thing on the list. It will hurt you if you're doing a high level language and you're interacting with lower level stuff if you do not think about memory the entire time you're working with something. You also have to think about error conditions, right? Because if something blows up and you throw an exception, you still have to deallocate the memory. That's what the finally block is for.
Oh, that makes sense.
Right. You have to think of every possible way that memory can escape your grasp before you deallocate it.
Yeah.
And close it.
Okay.
Because eventually, if you don't, stuff will fall over. And now, I guess this gets us into the next thing, which is memory access and variables. You're going to deal with a lot of pointers and a lot of handles. So instead of going, okay, I'm going to pass a string to this thing, you go, let me put this string in memory and let me get a pointer to the first character of this string. And then I'm going to call and pass this pointer to a Windows function.
Okay.
Right? That sounds reasonable, right?
Reminds me of some C++,
right.
Pascal stuff I did back in high school.
Yeah. But when you did it in C++ and Pascal, you didn't have the garbage collector moving the heap around.
No, I didn't.
And going, I don't know what this pointer is. I'm just going to leave it.
Ooh.
Even though I moved what it's pointing at.
Huh. Okay, yeah.
That's a bit of a problem because you don't know what you're pointing at now, but it's probably garbage. Or it could be sensitive. Hey, who knows?
Yeah, okay.
It could be something that you don't own, too.
Yeah.
Another thing that gets important is the concept of a handle. And you run into this more in Windows. Although I think you kind of have something similar I know you do in a couple of other like windowing type systems. Like I think Qt has them and all that. But basically what a handle is it's a pointer to the beginning of a memory structure that describes a window or describes a cursor or font or a system color or something like that, right? Basically what happens is if you have the handle, you can do something with that window. The problem is when you go, okay, I have a handle, but that window got destroyed and I didn't destroy the handle. If I pass that to Windows, it's like, WTF, mate. It's the Australian version of Windows, clearly, when this happens. The other thing that can happen is you could hang on to a window longer than you should. You're like, oh yeah, I made it invisible, or I closed it, or I deleted the handle, but the window's still out there and it's still consuming memory until you say deallocate this. And so that will burn you too. And the problem with handles is you don't get, like, even though it's it's typically like a double word, it's like a 32-bit. Mm-hmm. So you think, oh, well, I have how many gigs of RAM? Well, you maybe have like 2048 or 4096. I forget how many. There's a limit to how many of those. It's the same thing with files. It's the same thing with sockets. It's the same thing with all the low-level constructs. If you leak them, they are not available for the operating system. And when it runs out, very weird things start happening. I have starved my development environment of window handles, or graphics device context handles, actually, is what I did. Which is really interesting because it turns out that if you want to open the file menu to close something, it has to allocate a graphics device context to paint that menu. And if it's out of them, it can't.
Okay.
So it's just not there anymore.
Huh.
Now, I think they've fixed this a little bit better in newer versions of Windows, but like that was something you had to think about. Like, I don't want those leaking because I also have to click the magic start button to say I want to shut down the box and reboot it.
Yeah.
Bad things happen to, when you start doing that kind of stuff. I do think they have better protections now than they used to, but yeah, it can still cause a lot of problems. It can break your app.
Yeah.
At the very least. So you do have to be aware of what a handle is. Another thing that gets important is the memory layout of structures. So like, let's say that I have, like typically, .NET, like let's say I have a class, right? And I've got all these properties on it. Well, if I want to add a new property, I can stick it in the middle, right? Yeah. You don't do that with structures that are analogous to operating system structures and go, well, I'm just going to put this property in here and the OS can ignore it. Well, the OS doesn't read that by property name. It reads it by memory layout. And so you stuck another integer in there. You shifted everything past that by 32 bits. And it's going to say, oh, this is the window handle for the thing I'm doing because it's in that structure. Well, actually, it's a thing that's, how long is the title because I wanted to put that there.
Huh.
You can't screw around with those.
Yeah.
You have to be careful. I mean, typically, it's going to probably have error checking and blow up on you anyway, but you have to be aware of those as being a possibility.
I also think that dealing with pointers like that, callbacks would get really interesting.
Yes. In fact, I remember this dates me, Visual Basic 5, they had the address of operator. They added the ability to take Windows callbacks. You could not do it before that. It was like I have a function and I want to get the memory address of that function and pass it to something that says, hey, when you get this, like I'm going to do a global keyboard hook. So every time somebody hits a key, I want it to pass into my callback.
Okay.
You have to structure the callback in a certain way so that it knows, what's going into the stack frame because Windows is now calling you. So whatever, you can't just say, oh, give me these parameters and they're named. It's like, no, the first one is this. It's of this type. It's shaped this way. And you have to leave it alone. and deal with it inside the function. You can't just arbitrarily do things with it. So yeah, callbacks can get extremely interesting. Now, there's another issue too, and that is the way that function pointers work. Because if I have a procedural language and I have, a function called do stuff, and Windows calls do stuff on a WM Paint message or something, right? It passes a payload in, does the thing. Cool. Procedural language, no problem. But let's say I have a class that has do stuff on it. Okay, first of all, you don't want that to be, if that class gets disposed, how does it know the context that it's calling it under? So you're going to have it basically be static.
Yeah.
Probably to play well. You got to worry about those kind of things because it doesn't understand the concept of context. It's just calling stuff in a loop.
Okay, I follow you there.
That can get pretty interesting pretty quick, especially as you try to abstract things and say, well, I'm going to inherit from this and I'm going to do it this slightly different way.
I've been kind of getting a better understanding of static classes the more I work with extension methods, and then I've been doing some stuff where it's just like, all right, I need a place to put these things. So I've got like just basically a constants.
Yeah.
That is just like, all right, this is the connection to here. This is that. This is this. And I make those static because that way they're always there no matter where I'm at in the app.
Right.
I can use them.
And Windows kind of runs into the same thing.
Okay.
Because it's built for a much older paradigm. Like Win32 has been around. I think Windows 95 that had the 32-bit, seems like. So, I mean, that we have people in our audience that were literally not born.
Yeah.
When that came out, and before that, you had Win16, which was based on the same thing. So yeah, callbacks can be quite interesting. The other thing I mentioned earlier is if you're in a garbage collected language, you have to worry about the runtime moving stuff around. So like, let's say I say, hey, Windows, I have a bitmap and it's this place in memory. If the garbage collector runs, it will move it. So I have to pin it and say, hey, you can't move this object. It has to stay right there in memory. I don't care what you're doing. You're not doing that.
Yeah.
And you have to remember to do that or you have problems.
Yeah, that makes sense.
So, that can be a little bit painful.
Now, when you've got something static, does it stay there in memory or?
Yeah, it's at that address.
Okay, so it's not going to move if you make it static.
It's not static. You tell it to be pinned. So you have to get, there's a lot of hoops you have to jump through at a low level to make that, say, hey, look, memory allocator, look, I know you're trying to help me, bro. You're not helping me here. Quit. Okay. It just is what it is. You got to just mark it basically to say, you can't move this around. I'm sorry. Doesn't matter what you want to do. Because when it allocates a heap, it's got chunks of memory all over the place. It's not like it gets a contiguous block exactly. It does get like large contiguous blocks because of the way the memory allocation works and how big the objects are it has to put in there and those kind of things. So it's going to get big chunks, not just loose bytes. But it says basically, hey, this segment you can't touch.
Okay, I follow you. Yeah.
The other thing you got to learn about and be comfortable with is a lot of bit flags and masking and those kind of bitwise operations. Like I showed you, some of the stuff I've done in state machine type things before. And the reason is because this stuff is old. And there was a time when it really, really mattered how many bytes you were using. And, let's say if you have 32 options instead of having 32 Boolean values, which by the way aren't stored in a bit. In a lot of languages, they're a byte at least a piece, right? So you had 32 bytes for all this crap, which you may be transferring over a wire in a time with a very slow modem, or you can have a double word where each bit position means something different, and you combine them.
Okay,
right, using binary operators. That stuff's still around, and so you have to be very comfortable with that. It gets pretty interesting with drawing things or creating windows at a low level because you set the options. You say, hey, this has a title bar. This has a minimize button. Like those are bit flags. Now if you're using a typical framework, obviously it's going to wrap that stuff because nobody wants to deal with that.
Yeah.
But if you get low enough, you might have to.
Yeah, I mean these are things. They're problems that have already been solved for most
normal people, yes.
For most of what you're going to do, these were solved decades ago and have become part of the framework so that you don't have to deal with that.
Right.
But if you are working at that low of a level, you have to go back and think like they did when they were doing that.
Right.
Okay. I'm following you on this.
It can hurt.
Yeah.
The other thing is that it matters a lot who owns the memory. So let's say that you are trying to work with some other process. I've run into this talking to Delphi DLLs. But basically, if they allocate a byte array and it's not done in a certain way, you can't access it. That's an access violation because Windows has to keep programs separate. And you may think, oh, this is inconvenient. But think about in Chrome, for instance, when you're going to your banking website and then you have a video game that you're playing. You don't want that video game being able to read the memory that's in this other thing.
Yeah, that's true.
Right. So who owns the memory matters a lot. And you have to kind of bear that in mind.
So that's kind of why like new tabs in Chrome are their own instance.
Yeah, well, they also did that to reduce crashing and stuff. But yeah, that's part of the deal was a security thing, and also just figuring out who's misbehaving. And everybody points at Yahoo Mail because they leak memory like a sieve. Another thing that matters is who is responsible for allocating and deallocating memory, because you have different kind of paradigms for this. Like, I want one of these, give me one of those, and it says, okay, here's the thing. Well, you may be doing an operation that says, okay, you delete it or I delete it. You have to know who's doing that because you don't want to try to access something that they already deleted because they think they have ownership and that kind of thing. So that matters.
I think null is going to be messy.
Awful. Because null doesn't mean all the same things to all the same people.
Yeah.
At all the same times. Null is different than uninitialized.
Well, null is I don't know. It has no value.
Right. And uninitialized is also I don't know. And null is not really equal to null, and neither is uninitialized equal to uninitialized.
Yeah.
So like in 32-bit Delphi, just to give you an example, I can say, okay, I have an integer value and I don't initialize it, right? 32-bit Delphi, that's 0. 64-bit, it's whatever was in that chunk of memory. And you get nasty surprises, especially if you're doing compilation in both. Because your app might work in 32-bit and not work in 64. You have to remember to initialize those variables.
Okay.
Now, typically, a higher level language is going to have a default value. But the thing you're calling may not. And it may be passing something back that goes, yeah, here's some stuff. And you have to check to see if it's valid. Like, be aware that those can be things that can happen to you.
So, like, creating a variable like string the string and not setting it to an empty string or null is different than setting it to null. Right.
Although strings are not... as problematic, but yeah.
That was a string's a nullable type, right. And so I was just like, that's the first thing that came to mind.
Yeah, because they may give you a chunk of memory that goes, hey, this is where a string is supposed to live, but we didn't put one there.
Yeah.
You don't want to try to read that and put it in Notepad, because who knows what that is. It's probably going to be gobbledygook. The other thing is you got to remember not to tie the lifetime of unmanaged resources to the lifetime of the managed item that created them. This is particularly in garbage collected languages.
Yeah.
Like in .NET, if you have a class that represents a window and you say, okay, well, it's going to have the handle, it's going to have all this crap in it, right? But hey, I'm not referencing this thing anymore. Well, if it's still sitting on the heap with those references, they're still alive. And you now have no way to delete them until the heap deallocates them with the garbage collector, until the garbage collector gets them.
Yeah, okay.
Which can be bad.
Yeah, follow you there.
So you just had to kind of think through those sort of things.
Speaking of strings, I know we had a whole episode on them, but they have some particular nastiness when it comes to working low level in a high level language.
Yeah, ANSI versus Unicode matters a lot. Pascal string.
I'm sorry, I've been catching up on Agents of S.H.I.E.L.D. Season 3, Sky, Daisy, whatever they're calling her now. Like, what's up with changing a character's name halfway through the show? Like, 2 seasons in, we're going to change her name completely. Anyways, but she says she's the hacker on the show, and she's like, converting to Unicode. I'm like, to hack into, the security system?
Yeah, because we're going to use Unicode characters in the passcode. Well, I mean, if you go low enough, though, it's a byte array.
That's true.
And you have to know how that byte array is organized to be able to talk with that byte array. Another thing you have to be careful about, and this is not as big of a deal as it used to be, but you had to be careful about string length due to overflows or underflow type things. So like you might have, like if you have a Pascal string, you've got the number of characters in it. That's the first byte. And then you have the bytes.
Yeah. Okay.
Whereas other types, it's null terminated or whatever.
I remember null terminated when, I think in Pascal.
Yeah.
I'm remembering a lot of these. Mind you, this was high school. It was a while back for me, but Yeah, I remember a lot of the terms and kind of like an idea of what they are.
Yeah. So sometimes it's possible to pass an array and then pass a length, or basically pass something that is too long for what it's going into, for however you manage to be doing that, and you touch a parameter that you shouldn't, or you touch basically the stack frame in such a way that when it comes back out of that function, it jumps somewhere it's not supposed to go.
So you got some inappropriate touching going on.
Right. It's a buffer overflow. Like you don't have to worry about that as much as you used to.
Yeah.
But that possibility is still there. So it can bite you, especially if you have code that's internal to the company you're working for, and it's not externally exposed. Yeah. And all of a sudden you expose it through the web, and somebody passes something in that's too long, and you're not trimming it or whatever. You can get burned. So you have to be careful about that.
I can see that. I had some issues with that, with doing image uploads and downloads. Where JSON cut you off at a certain size, so we had to switch over to doing form data.
Right.
For transferring images. So speaking of that, the next point is image nastiness.
Yes.
And you have to worry about how images are handled in a way that your high-level language abstracts.
Right, because you probably go, okay, I create a new image.
Yeah.
And then I only care about the pixel depth or whatever when I'm saving it, which means typically that, okay, we're gonna basically make this a really high-quality image in memory. You do the stuff with it, and then when it's time to save it, we'll encode it differently.
Yes.
Because, they can't make it have a higher resolution going down to disk. Like, it's got to be at that high resolution in memory. So it takes a lot more memory. So, you can make things smaller and faster and tighter if you take it lower. But for instance, if you try to save a JPEG, there's a bunch of different codecs for how you save a JPEG. If you deal with things like, okay, I want to draw a piece of text on this window. Well, you have to think about how colors get interpolated between the background and the text.
Okay.
Right. So you get low enough level, you start dealing with those kind of things. We at work, we've been dealing with an issue where you try to create a graphics device context, right? Because you're going to draw and you're going to do a preview of a PDF because you got a WYSIWYG editor, right? Well, the PDF is printing out at 300 DPI. Okay. Your screen resolution is 96 DPI. Guess what kind of graphics device context you can't get? Right? That is completely unhelpful.
Yeah.
Because it's like, well, you're drawing to screen. But I'm not drawing to screen. I'm trying to represent what it looks like on the printer. And you got to deal with those scaling issues all the way down.
And we had this issue with printing out permits with SSRS.
Yeah.
Because we were doing the approved permit layout as the background image, and then overlaying, the specific details for that permit on top of it. And to get it to print off to the right places, it had to be like way over to the left and down some. It's just like way off screen.
Yeah.
On the designer and like setting that up. But then when you go into print view, it's in the right place.
Yeah. And that can, like, world coordinates versus screen coordinates is a whole nother ball of wax. I'll tell you another example that hurts a lot is if you have worked with OpenGL in the past and you decide, hey, I'm going to use Microsoft DirectX because DirectX has a left-handed coordinate system. So the Z-axis, instead of doing like everybody else in computers, right, where, okay, as the Z-axis increases, it's coming towards the viewer, theirs goes away. So every time you say, oh, here's the transformation matrix I need to rotate this thing, it ain't that way. You've got to know linear algebra to convert it to what DirectX will need.
Wow.
Because reasons. I don't know why they did that, but I ran into that and I'm like, yeah, I'm not doing this. Sorry. I was bad enough at OpenGL. I don't need to get bad at this too.
Oh, wow. That's...
yeah, it can be really painful. The other thing is your OS, the graphics engine under it was built in a very different time. So like in Windows, you say, okay, I'm going to set the pin, right? And I have a handle to a pin object. And then I'm going to draw lines. Well, as long as I keep drawing lines, it stays on that same pin, and then I have to change the state. So it's stateful. It's not a thing of draw a line, black, this width, from here to here. It's, okay, set the pin to black, set the width to this. Actually, you set both, and then you set your segments, and you got to pick, you got to constantly be changing all that stuff out. It's very stateful all the way through. And that can be a little, there's some stuff in there that can be a little quirky. And, I mean, it's just stupid stuff. Like I have to think about how when I end a line segment and I go to a point or go to a vertex that I'm going to draw from, how that point gets drawn.
Okay.
And I have to set that on the pin options with a bit flag. And I have to know what those flags mean. Yeah, it's just a lot of annoying stuff. Plus, you also have to set how it renders it. In other words, is it rendering it by rendering a black line, or is it doing a bitwise operation on the pixels already there? Because that's how you draw a rectangle that you can erase. It's because you just redraw it, XORing again, and that makes it always stand out.
Yeah, I follow.
Right. So there's stuff like that. Yeah, there's really a lot of stuff as far as images that get kind of painful. You're probably using a GUI framework if you're doing a lot of this stuff. Another fun thing that will happen to you, depending on what you're using, or if you're using in-house components that somebody clever built, and you go, hey, I want to make this button look a little different, and I've got to use the Windows API to do it. You may go in there and find that control doesn't exist as far as Windows is concerned. The background of the form exists, and everything is owner drawn on there. And it's just your system is reacting to it, but there's nothing that Windows can touch.
Oh, wow.
Right. You may legitimately find that. Because those people probably said, hey, I'm going to owner draw this because I don't want to deal with Windows. And 10 years later, you go, I've got to do this with Windows. Let me fix this. Oh, wait, I can't. So just bear that in mind, too. That may get you. Now, the next section is thread and process nastiness. And
don't even bother with your async primitives.
Right. Like if you're doing low-level threading stuff, I mean, they have some capabilities. But the other thing in .NET is sometimes, there's a difference between multi-threaded and async. And if you don't understand those real well, like trying to make async work with OS threading is probably not going to be a happy place for you. It's not going to be a happy place for anybody that's around you, as a matter of fact. Because you're going to have a really bad time.
Man, we were all sitting in the conference room because we were kind of doing a code along learning thing, and then Cody and I were working on something else because we have a very strict deadline at the end of this week, and I was getting frustrated. And I was smacking my hands on the chair, and then I finally figured out something I told you earlier, just a stupid thing that I messed up.
That was stupid. Huh?
Yeah. Looking back, I'm like, I can't believe it was just something like. And if the ORM hadn't eaten the error, I would have found that out within minutes. But it took me hours because I had to go track down the error to figure out what I'd messed up.
And by the way, that's what will happen with all this stuff. A lot of times it won't give you much. I mean, we'll get to that in a minute.
But no, what I was getting at was I kind of scared one of the other developers because I smacked myself in the head really hard when I figured out what it was. And she jumped and looked over. She's like, you guys are scaring me. And I'm like, you didn't sit by us when we were all in the office all the time. This is normal.
Yeah, we've toned it down. But you'll be doing that if you're dealing with threads and processes at a low level. One thing that gets interesting with threading at the operating system level and dealing with especially when you start getting low enough where you're dealing with stuff like mutexes and those kind of things, which I've done twice in my career. I do not intend that there be a third time, is where data lives, because you don't have stuff that says, hey, only one thing can hit this at once. Like if you want that, you make that.
Okay, I follow you.
Right? You want a gate around your property, you build the fence and the gate and the property and the grass, and you grow the trees for the fence, and you forge the barbed wire. Like you don't have any of that stuff when you go low level enough. So just bear that in mind.
It's like playing Minecraft. Yeah.
Now, that sounds all well and good. It sounds like a lot of fun. But let's say that you have two threads operating, and you need to get data from one to the other. How you move that data is called marshalling. It's also how you move data between processes and those kind of things, right? Well, you might say, okay, I've got named pipes, and I'm going to serialize the data and push it over and deserialize it. But you basically have to come up with your own protocol for those kind of operations. And you may be talking to somebody else's thread that almost reads your data right?
Yeah.
Let's say that they go, hey, I'm passing it a string and I'm encoding it as a Pascal string because that's what they accept. But you don't know what the max length on a Pascal string is because you didn't read the API docs. So you occasionally pass one that's 300 characters and stuff blows up because their system goes, well, I don't know what this is. Or your system does it and eats it. All kinds of weird stuff can happen. So you do have to kind of be aware of that. There's multiple types of threading environments as well. There's, what they call apartment threading, which is a lot of your COM apps will have, or really heavy COM stuff will have. That was the big thing in the Visual Basic days. And there's a lot of architectural reasons for that I didn't completely comprehend. A friend of mine ran into an issue, and he's probably listening because he's won something on here. So he obviously listens at least a little. But he ran into an issue where he was trying to automate PowerPoint using .NET. Yeah. .NET's, true multi-threaded.
I know the friend you're talking about now.
Yeah. And he's talking to PowerPoint, which, if I recall correctly, is apartment threaded.
Yeah.
And, it's like I can do stuff on a slide, and it's taking like 4 minutes to do it. And it was because he didn't set the STA thread attribute on his main process in .NET to say, hey, this is a single threaded app. Don't do multi-threaded because I don't want my marshalling screwed up to talk to this other thing. It looks like it's completely unrelated, but it was going that slow, trying to make it essentially thread safe for the other side to deal with the data. It's horrendous. And he mentioned it, and I had like this flashback to sitting at the oil company, my dad's oil company, at the computer working on Windows NT, trying to do stuff with Visual Basic, talking to Office, and reading about that stuff. Like, this was a long time. This was 20 years ago. It was more than 20. And that stuff is still around. Clearly, I've managed to dodge that particular bullet since then, but other people haven't. So you have to be aware of that. Yeah, so that can be really painful. Another thing you have to deal with sometimes is hardware. Your machine may be abstracting the hardware. If you're going low level, you're probably doing it to get closer to the hardware so that you can do things faster, or you can do things that aren't available at the higher level construct. So you have to think about things like the bitness. So like, is this 32-bit or is it 64-bit? If I load a Delphi DLL that's 64-bit and I try to load it in a 32-bit environment, it won't work, right? And vice versa. A lot of things work differently. And so my assumptions are going to be wrong. So you have to be aware of that. What can the processor take and what environment am I loading up on it? There's a lot of driver level stuff. There's, variations in hardware. You may get low enough level where it's like, hey, I can talk to this network card this way from this high level language, but my buddy who has the exact same model of hardware card can't. And it turns out that there's a different chip on the card that has the same model. Like, you will run into those kind of things if you get low enough level. And most of the time you're not going to if you're doing high level stuff. But you might if you're building like a wrapper for a driver.
Or if you're messing around with IoT stuff.
Yeah. I mean, that's a good place to get.
I could see that, especially as they get, things get cheaper.
Or as they start deciding to focus on security.
Yeah.
Which apparently hasn't happened yet. But, someday.
We'll be there.
Yeah. The other thing you have to worry about is little stuff like power events. How does your app handle power going? Well, right now, most of the time, people write it and they don't care. You write a Windows service, you have to think about those kind of things. You start dealing with even lower level stuff, you'll get a power notification and you have to be able to shut off in a certain amount of time. And that stuff will come up.
Talking about IoT stuff, some I/O issues, input-output issues, reading from and writing to disk in the wrong way can absolutely slow you down.
Yeah, and the same thing with allocating memory.
Mm-hmm.
Like, you want to, just because you go, okay, I only need like 10 bytes right now, but I'm going to need 1,000 later, go ahead and get the 1,000. Like, it'll be faster that way, probably.
You got to be more careful how data is laid out in the files.
Right. And an example of this is where you're navigating, you're jumping around the file, reading. You typically don't do that in web apps.
Yeah.
Like, that's not a thing. You put it in a database. But if you're going, hey, I'm going to go low level and I'm going to treat this like records, or I'm reading stuff that came off of VAX,
VAX?
Like the old VAX machines. They're still around. Or
really?
VMS and all that. I mean, those things are still around. There's stuff in COBOL that's still running. Probably where you work, if you talk to the right people.
Well, my
and you probably have enough of a beard you could actually go in the room with them.
My executive director,
just as long as you don't touch anything,
that runs our division, started off as a COBOL programmer.
Yeah,
and I heard on .NET Rocks a few days ago about visual COBOL.
Yeah,
and I was showing that to her. I was like, yeah, you could do object-oriented COBOL. And like, I say this to her at a big workstation with like 3 or 4 other developers, and she's like, yeah, talking to me about it. Like, they all look up like, what?
Yeah. But I mean, you have to think about how you jump around in files. And when you write stuff to a file, at a higher level language, it's like your runtime is slow enough that you may not really care as much. But when you're going low level, you're doing this with a purpose. And so you go, okay, I know how big these records are, and I'm going to seek to this point in the file and do all those kind of calculations. Like, that's something you're going to probably have to think about.
Mm-hmm. That's true.
It really is something you should think about at a higher level too, if you're doing that kind of stuff, but people don't because they can get away with it. You also have to be careful about closing sockets and other connections. You may also be dealing with low-level networking stuff. So, like, for instance, if you and I are writing a game, right, and, it's a multiplayer game and two pieces are talking to each other, we're probably not going to be using TCP/IP, right? So I have to think about the fact that I send a packet to you and it never arrives.
Okay.
How do I recover? How do I make it where you can get caught up?
I follow you, yeah.
Without having to go, okay, here, send a packet. Okay, did I get it? And dealing with the act, because you're going low enough level, you probably actually need that kind of bandwidth. Mm-hmm. So that's something that can come up as well. Next
is loading libraries. You have to know the calling convention for the libraries you load.
Right. And this is stuff like your C declarations versus, Pascal or Delphi has got a thing where you can say, hey, this variable that's getting passed in doesn't get put on the stack frame. It goes into a CPU register. And it can figure out, like the compiler can figure out, okay, yeah, this is where this thing goes. Well, if I expose one of those to you, you can't call it from .NET, as far as I can tell. If somebody knows better, please inform me. I would love to know about that. But as far as I've been able to figure out, you can't do that. And so you have to know whether it's a standard call or a C declaration. And the way that those parameters go in the stack frame is different. And let's say you're passing 3 integers. The order may be different, for instance. Like, it may look like, okay, they wrote it in here and it's this, it's ABC, but I have to pass it as CBA because of the way that it interprets the stack. You just have no idea, just get braced. So that can be an issue. You probably won't run into it unless you're doing, you probably have somebody on the other side that intimately understands how the stack frame is organized and all that if you're doing that.
Okay. Also, you may not ever get a real stack trace, but rather something like just an access violation.
Yeah. My favorite is if you are calling GDI plus libraries from .NET, you say, okay, I want to draw this thing. And this can actually happen in managed-ish code. That's like that light wrapper that they put around stuff. It says unspecified GDI plus error.
Oh, yeah.
It's like count to 4 on your fingers in binary. That's what Windows just told you. And there's some nerd out there that's, probably looking at their hand right now going, oh. Yeah, buddy. That's what they're telling you.
That's good.
Another thing that can happen is if you are, loading another library, you're in a sandbox environment, your code may not, or the framework you're working on may not let you load these other libraries. That library has a certain set of permissions that are required to load it. Your sandbox environment may not let you load it. It may say you can't interact with the OS directly. You have to come through us. It's very legit to run into that. It used to be very common in web server environments. So it's like, hey, I want to resize this image for my website. You get number 4, man.
Yeah.
It's the Windows just gives you the finger and it's like, no, you're not. And that's something that can happen. You actually really have to be really aware of your execution environment in general. Let's say your code's not compiled or it's compiled to some intermediate form. You may need to be concerned about timing and about what things you have and when. So, like if you're dynamically loading assemblies in .NET and you say, okay, I have, and this, I don't think this has been an issue for a long time because I think they've kind of figured out, hey, wait, we can't have this problem. But, if you were dynamically loading it and you're saying, okay, give me the function, that's named this, that's, static or whatever, and it's in this assembly on this class. If that assembly is not loaded, that function pointer ain't going to help you.
Yeah.
Now, you typically will get an error now.
Okay.
Depending on how you access things. There's ways to do it where you won't. But it used to not be quite so good about that. Mm-hmm. Or you have to worry about, okay, I've loaded up in a separate app domain and I've loaded these assemblies in there and now I'm going to get a pointer to this thing. But then I unload the app domain and it was a callback. Now Windows is calling back to what?
Oh, okay.
Something that you deallocated. So you have the problem that Windows had when you were passing it bad pointers. It can do it to you too.
Oh, yeah. I see that.
So you have to remember, like, if I hook something into Windows, I have to unhook it when I'm done with it. or I get to reboot my machine, probably.
Hopefully.
Yeah. If I want that to go away.
Yeah.
So you definitely have to be somewhat cautious about that. If you have just-in-time compilation things, like let's say you have something where Windows is calling back into your thing, and let's say it's a power management event, right? And you're handling that, or let's say it's a service shutdown, whatever. But you've handled that in a separate chunk of code, separate assembly. If that thing is not already gone through the JIT compilation the first time Windows calls it, and Windows says, hey, you've got 60 seconds to respond to this call, or you've got X amount, some small amount of time potentially, and if you don't, I'm just going to kill the process. There's stuff in Windows that will do that to you. So you got to make sure you get that assembly hot.
Yeah, okay, I follow you.
Beforehand. So there's some of those little timing issues. Most of the time you won't get hit by that, but like on your laptop, it could happen easily.
Another thing, the low-level code may execute outside of the safe sandbox that your framework provides.
Right. And, that can also cause you problems, like especially if you are kicking off other processes and you're saying, I'm going to make a website that lets people arbitrarily execute a PowerShell script on my machine. If you do that, you're an idiot, by the way. But, let's say that you are an idiot. You can do this and shoot yourself in the foot, kicking that off in another process.
Yeah.
You have to bear that in mind. The execution context of lower level code is very different than yours. And it's easy to introduce vulnerabilities that way if you're not thinking through things well. I worked at a company that we had a section in the database where you could put your own C# code for validating incoming data. And so when it had a piece of this kind of data, it would load this thing up, build a dynamic assembly, and then you could push the code at it, right? So you could shoot yourself in the foot with .NET or some higher level language this way too.
Yeah.
But when you get lower level, it gets a lot uglier to try to stop that, especially if it's running a system. Always be smart about that. And think about the OS permissions that you are executing under. In fact, and not all the details have come out about this, but by the time this episode airs, there was a nasty issue with the Windows Defender engine. And as far as I can tell, what it looks like it's doing, again, according to early reports, is that it is saying, hey, you saved a JavaScript file to your system, or this JavaScript file showed up on the system, including in a temp folder. Let's run this in a sandbox and see what happens and see if it might be a virus. And somebody wrote one that escaped the sandbox.
Yeah.
That kind of stuff is very doable. When you start messing with a system, there's fewer safeguards against something that's already running on the box, because the box has to be kept fast.
Yeah, that makes sense. We've kind of already talked about this next one a little bit, but your chosen framework might wrap low-level errors in something stupid that doesn't help you at all. And we mentioned the unspecified GDI plus error. You might also get an error number that you have to look up. I love those. I get those through Oracle.
Yeah.
A lot.
And those big, long error numbers. And, oh, by the way, everybody else has a numbering scheme, so you can't just put that into Google, because it might be a phone number. My favorite was calling some low-level Delphi code that had a third-party component in it, and it was intended to be run in Windows. And so when my code passed a call to it and said, hey, do this thing, their code said, hey, you don't have a license for this. Here's a message box telling you so. That's great, except I'm running in a web server context and nobody sees a message box ever because it's running as the web server user on an account that literally no one ever logs into.
Yeah.
And you know what it does? It just locks up the web server. And that kind of stuff is very, very possible if you're not smart about the execution environment. If you don't know everything that's going on, you get bitten. There's a reason we abstract this stuff away.
The last consideration you really need to take into account is your team.
Yeah.
If you're doing low-level code in a high-level language, you're going to have trouble finding a team that actually understands it.
Yeah. The way I would put this is good freaking luck. If you're doing pointer manipulation in C#, which I have, or if you're using volatile, using the volatile keyword or using unsafe code blocks and those kind of things where you're, not only are you dealing with pointers, but you're dealing with pointer math those kind of things, or pointers to pointers. Yeah. Other .NET developers, if they come in there and they see that, they're going to have a bad time, especially if they have to fix it.
Yeah.
And you're generally better off to avoid this any way you can.
I think also a lot of refactoring is going to be difficult.
Yes.
Especially if you're trying to refactor for understandability or reusability.
Yeah. Well, and if it's low-level code, you don't do that.
Yeah.
That's the thing people, that are really into refactoring forget. It's like, no, when it's low enough level code, it's low level like that for a reason. It's not, you're not intending to aim it towards the person. You're aiming it towards the computer, understanding it and doing it quickly. Yeah. And it may be just, god awful. And that's the way it's got to be. And if you clean it up, you may make it really slow. You may put a function call in there and suddenly now you've got another jump and it's calling that function, millions of times.
Like converting an array function parameter to IEnumerable.
Well, yeah, that'll burn you too.
Yeah.
And ReSharp or some of these tools will actually say, hey, you can, you have the opportunity to convert this, which is typically fine. The problem is if you get that array in and you go, okay, I'm going to pin this in memory and then I'm going to, call this API. It gets even better when you have conditional compilation constants, which you're going to have if you're doing 32-bit and 64-bit.
Yeah.
Because you got to call different APIs with it or you got to do some different things with it.
Mm-hmm.
If you have that too, a lot of those tools just freak out with those and they'll give you stupid suggestions because not a lot of people do that.
Yeah.
But if you ever do, your tools will betray you.
Also, your low-level libraries probably not going to be in your package manager.
Yeah. So like you're using NuGet and you go, okay, I want to use really even some .NET tools are not in there at this point. So maybe that's not even a good example, but the package that you're trying to use may require some DLL that if they didn't build it just right, it doesn't show up. Or if you want to add it to a project or have it where it is available for the purposes of a CI server or something along those lines, you're going to have to make your own NuGet packages for those things. If you want that in that stream that way, it's not going to be provided for you. That can get pretty nasty with the rest of the team.
I can see that. Because
you build something on your box and, it works on my box. But everybody else has to go through, 2 days of setup to get where it works on theirs. I mean, that's the biggest pain point I have with Delphi right now is just, okay, I pulled down this project, but I have to pull down these other 4 projects, and then I have to pull down 2 projects apiece for those, and then this other thing, and I have to build them in the right order, or I can't build the thing I'm actually trying to work on. Package management is a big deal with high-level language, and the people at low-level language do not care about that at all.
Yeah,
that is not something that is on their radar whatsoever. The other thing is you'll run into stuff where it's, you may, like, let's say you're building something on Windows 10, and you're deploying on Server 2012, as an example. Well, there's low-level stuff that is on Windows 10 that isn't on Server 2012, or the calling conventions are different, or that it's more locked down on the server.
Yeah, that makes sense.
And you have to worry about OS compatibility at a level you don't in a higher level language.
Mm-hmm. Realistically, you're probably going to be better off writing low-level code in a real low-level language and then calling it from a high-level language, rather than trying to do too much low-level stuff in a language that wasn't designed for it. Well, that said, you will run into cases where you have to work with lower-level constructs if you code long enough. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to throw out something I kind of hinted at earlier, and that is that not all programmers have the same priorities. It's very common for us, and we do it here too on the podcast because we both do high-level languages and web stuff, to not have the same priorities that a low-level programmer would have for things. So stuff like package management, if it's a C developer, they probably don't really think about that as much. They've got other problems to deal with. If they're doing, device drivers or, even lower level type stuff than that, they're not thinking in the same headspace you are. It's important to not project your personal headspace onto someone else who's doing something completely different. This works with all IT folks. I can't count how many conversations I've had with support people, for instance, who have completely different priorities than developers. Or developers who are doing other things, like they're developing database applications. Their set of constraints that they're living under are completely different than yours. And I'm just going to throw out here that you're probably better off, if you're talking to those people, to talk to them in terms of the constraints and the priorities that they have versus the ones that you have, if you actually want to get things done. Now, if you want to have an argument, totally go talk to them about your priorities. But don't start there if you actually want to get something done. That's all I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.